Assalamualaikum warahmatullahi wabarakatuh. My name is ILMAM BEJ41103 and my case number is DHIYA. So this is our project for digital communication. So we are from Group 5. Our group members is the AKMAL bin Ibrahim, the E110064, Muhammad IZWAN HASHIM bin SYAMSYUL AMRI, CE200107, me myself, Arif Iman BEJ411, the E200104, Ahmad AKMAL bin Ahmad BADRUDDIN, CE200145, and finally Muhammad Deni Putra bin Shahrulnizam, CE20025. So I'm gonna talk about the project background. So the project aims to address the fundamental facts that degrade the code performance in wireless communication system, differ, especially focusing on the time-varying nature of the channel and interference. These effects, such as multipath shadowing, and path loss, result in fluctuating signal-to-noise ratios at the receiver's output, leading to degradation in the system's bit error rate. The communication system diagram serves as a framework for the proposed techniques to reduce the bit error rate. MATLAB Simulink will be used to investigate and analyze the effectiveness of these techniques in improving the system's error performance. So that's all for me. Next, my friends will continue the discussion. Thank you.
Assalamualaikum and hello everyone. So my name is Muhammad Putra bin SHAHRULLNIZAM, metric number CE200225. So today I want to present about project digital communication and I'm from group 5. So this is my problem statement. This is the number one is variation, which are the consequence of multipath fading, shadowing and path loss cause an unstable signal to noise ratio, which is SNR, at the receiver. Now, second is the fluctuating SNR has a negative impact on the efficiency of the system, resulting to an increase in bit error rate (BER) and a decline in overall communication quality. And the third one is wireless communication system frequently operate in environments where multiple interference sources, such as other wireless device, neighboring network, and environmental noise are present. And the last one is this interference introduce extraneous signals that interfere with the intended communications, leading to a decrease in signal quality and an increase in bit error rate, which is BER. So we go to my scope project. My scope project is have five. So the number one is the project will involve identify and proposing suitable technique that have the potential to reduce the BER in wireless communication system. Second one is proposed technique will be implemented using MATLAB Simulink. MATLAB Simulink is a widely used simulation environment for system level design and analysis. The third one is this project will conduct appropriate investigation and analysis to evaluate the performance of the proposed techniques. Next, the main goal of the project is to demonstrate that the proposed technique effectively reduce the BER and improve the system error performance. And the last one is the project will include the validation and verifications of the proposed technique through rigorous testing and comparison. So the next will continue with my group mate. That's all for me. Thank you.
Okay, Assalamualaikum and hi. My name is Muhammad AMRI. So for my part, I will present about the block diagram and the system description. Okay, for the block diagram, we have information source, BPSK modulator, AWGN channel, BPSKD modulator and destination. Okay, for the first one, which is information source, it is the entity of systems that produces the information to be communicated. BPSK modulator, it converts binary data into a modulated signal by shifting the phase of a carrier. For AWGN channel, it simulates the effects of noise in practical communication systems. For BPSKD modulator, it compares the phase of the received signal with a reference carrier signal to determine the binary values. And lastly, for the destination, It is intended as the end or endpoint of the transmitted data. Okay, next is system description. Okay, to reduce the bit error rate (BR) in the systems, various techniques can be employed. First one is A. Error correction codes. Using error correction codes such as forward error correction (FEC), redundant information is added to the transmitted data. This allows the receivers to detect and correct errors introduced by the channel, thereby reducing the PER. Second is channel coding. Channel coding techniques like convolutional coding or Reed-Solomon coding can be employed to enhance the robustness of the transmitted signal against noise and interference. C. Equalizations. Equalization techniques can be applied to mitigate the effects of multiple fading and improve the signal quality at the receiver. D. Signal processing algorithms. Advanced signal processing algorithms can be used at the receiver to enhance the detection and decoding of the received signal, thereby reducing errors and improving BER. And lastly, modulation and coding schemes. Optimizing the choice of modulations and coding schemes based on the channel conditions and system requirements can also help in reducing the BER. Okay, for the next slide, I will pass to my friend. That's all for me. Thank you.
Assalamualaikum, my name is Ahmad Harith AKMAL, Robotic CE200145. So this part is I'm going to show about the simulation of the MATLAB Simulink. So to give the effect of the fading, multiple fading or shadowing and path loss, we introduce the system block diagram to Rayleigh fading effect. So let me show you the MATLAB. Okay, so this is the block diagram that we created without the fading effect. So let me show you with the fading effect. So as you can see, the signal strength has from the first one. Let me show you. There we got, and also from this. Okay, so as you can see, the signal strength has decreased by 20 decibel after the Rayleigh fading effect. So this means that the signal is now 100% weaker, 100 times weaker. In other words, for every 1 watt of signal power that has transmitted, only 0.01 watts of signal power is received. So this is because it's caused by the random scattering of the radio waves of objects in the environment. So this scattering can cause the signal to arrive at the receiver in a weakened state. So the amount of weakening depends on the number of size of the object that has the signal encounter. So there are many ways to improve system error performance by using Rayleigh fading effects. So one way is to use multiple antennas at the transmitter and receiver. So this technique, known as MIMO, can help to improve the reliability of the communication link by providing multiple paths for the signal to travel. So another way to improve system error performance is also to transmit the signal over multiple frequencies. So this technique, known as frequency diversity, can help to mitigate the effects of Rayleigh fading by ensuring that at least one of the frequencies is not affected by fading at any given time.
Okay, my name is AKMAL IBRAHIM. Now we go to the final output analysis. So this is the graph that we obtained from the BER analyzer. So the graph above shows the performance of digital communication system with and without Rayleigh fading technique. So the gold one is without Rayleigh fading technique. The purple one is with Rayleigh fading technique. So in terms of bit error rate, and also EV over N naught. So the graph also shows that the value of SNR for the system with Rayleigh fading technique is lower compared to the system without Rayleigh fading technique. This means that the system with Rayleigh fading technique is able to provide a higher quality of the received signal. So next, we're gonna see the scope block diagram for the system. So this is without Rayleigh fading effect, and this is with Rayleigh fading effect. So the figure above shows the different result from the scope of with and without rarely fading effect. So the first waveform, so this is the first waveform, and the last waveform is actually to indicate whether there is an error in the system. And the second waveform is BPSK modulation, and the third waveform is BPSK demodulation. So um, by looking at the scope block diagram for the system without a Rayleigh fading effect, we can observe that the first and last waveform is have more disagreement than the plot diagram for the system with Rayleigh fading effect. So as we can see from here, the first and the last waveform have more disagreement, which is there's not the same. But when we look at the with Rayleigh fading effect, it's quite the same. The similarity is high than the without Rayleigh fading effect. So this means that the Rayleigh fading is still an effective method for reducing the error of the system, even if it is not able to eliminate all the error. So next we go to the discussion. So the Rayleigh fading effect reduce error in a digital communication system, although it might not eliminate all errors, but it shows a lower bit error rate and total error compared to a system without the technique. So and also the signal to noise ratio is lower in the system with the Rayleigh fading effect, indicating a slightly lower signal quality. But however, the technique is still effective in reducing error. So careful consideration is important when choosing error correction techniques based on the system parameter. And that's all from us. Thank you.